Welcome to ASOC Tutorials India program, a platform to learn amateur radio in India. And before I start today's session, just I want to re-clarify my tutorials are not made for any kind of competitive exams like joint entrance exam or similar. This is purely a technical hobby, no need advanced details. So my tutorials are only just to qualify amateur radio examination in India. Before I go to today's session, it is a time to recap previous sessions. First, go and watch previous session because my session is continue to previous session, and today's session is Superheterodyne Receiver. And just recap: tuned radio frequency receiver, antenna receiving signal and converting to electrical signal, RF amplifier, AM detector, audio amplifier and speaker, and finally we are listening the audio transmitted by the broadcast stations. And of course a power supply is very essential to work a device, electronic device. Here you have to remember characteristics of a receiver, mainly sensitivity, selectivity, fidelity and stability, all four explained in previous sessions. One thing is very important, this TRF is one of the simplest form, not have so many complicated stages like mixers and IF operations, and it is very much suitable to receive a single frequency and channel, and it is already pre-designed, so everything is good, so selectivity is also good. But this receiver is tuned on one frequency, spot frequency, and if the frequency itself is drifting or changing due to any reason, then this become unstable. And bandwidth if changing in the receiver, then center frequency is also changing, so it is not good. And the gain of TRS is not uniform or wide range of frequencies because components like inductors and capacitors, they are frequency dependent and they are not uniform responding. So there is a different response on different sets of frequencies. Due to above disadvantages, TRF receivers are not practically used in AM reception nowadays, and superheterodyne receivers are commonly used since they offer many advantages, and this is you have to understand in today's session. So superheterodyne receiver works on principle of heterodyning, which means mixing. Mixing means there are two frequencies. One is incoming and one we are going to create locally and going to mix both frequency, and result we are going to use it, and that is called intermediate frequency, in simple term IF frequency. Now telling again, this superheterodyne receiver converts a modulated received signal to a fixed intermediate frequency by mixing the received signal frequency incoming with the frequency signal generated by local oscillator LO, which can be more conveniently processed than the original carrier frequency. And one more thing you have to understand, I have mentioned fixed intermediate frequency. It means if incoming frequency is going high, local frequency will also go high. If incoming frequency is going low, local will also go low. In every time the IF will be make stabilize, so that further response by component will be uniform. And virtually all modern receivers use a superheterodyne receivers, except those software defined radios using direct sampling is also nowadays in use. How this superheterodyne receiver works, a block diagram. First component is antenna, a metal rod or piece of wire that received or catches radio wave, I can say electromagnetic waves, EM wave, and turns them into electrical signals feeding into radio receiver. This is very millivolts or microvolts. This milli or microvolts go to the RF amplifier stage. As the name is amplifier, this RF amplifier stage amplify the weak received modulated signal from antenna. This is one term it is doing. Second term, there is an inbuilt tuning section, tuning the desired channel and rejecting the undesired or channel or unwanted channel. So two terms are there, one amplification and second tuning the desired channel. Now one frequency we have, incoming frequency. We need one more frequency, local frequency. This local frequency is being generated by local oscillator, and this two frequency will go to a mixer stage. What mixer stage will do? This mixer stage will mixes the carrier frequency with the frequency of the signal generated by local oscillator. So mixer have two frequency. Result, we are taking output as an intermediate frequency. How mixer is working, I can take in details in some other supplementary sessions. Here I am going in simple terms. This IF amplifier amplifies the weak received signal from the mixer stage, which is 455 kHz as a normal, and amplifying it. Now we have fixed frequency irrespective of incoming frequency or channel. Whatever may be channel, but here we have 455 kHz fixed frequency. Now next part is AM detector. This AM detector needed to explain briefly also, because after that FM detector, SSB detector, so many detector, or I can say demodulation stage will become. So going next, audio amplifier. AF amplifier amplify the weak signal received audio from AM detector and amplify audio signal to a particular level. So this stage will amplify the weak signal, audio signal, and last speaker. Loudspeaker or speaker will convert the electrical form of signal into an audio sound of signal. In other words, I can say it will convert electrical signal into acoustic wave or sound wave. And now this vibrating signal will come to our ears, and result we will listen the same audio which is being broadcasted by the transmitting station. This is a block diagram of superheterodyne receiver. And of course, don't forget, we need a power supply stages to give power to the all stages. Of course, antenna don't require a power, but we have to assume that every stage is getting power. So now coming same TRF receiver, but just showing a waveform also, how the waveform goes. This is also very important. First, antenna is receiving very millivolt modulated signal from the ionosphere. RF amplifier is tuning the desired frequency and amplifying it. Local oscillator is generating a very high frequency and giving both sub frequencies to the mixer. Mixer is mixing both frequencies, and result is IF amplifier. Slightly this frequency is fixed at 455 kHz, and this IF frequency after amplification will go to the AM detector. And now here you have to understand very carefully the working of AM detector or AM modulator, a demodulator. How AM demodulator works? First, a diodes converts the modulated signal to the positive modulated signal. You can see on blue graph. Now what happened? Next one is C1, capacitor. What capacitor will do? It will fill the gaps between modulated waves. Result, this high frequency, IF frequency, become low frequency. But here I want to update you. This output of AM detected diode D1 contain DC voltage because there is no AC component. modulating signal. You see the wave shape is modulating signal as per IF signal, and RF ripples. It is in pulsating form. This RF ripples will be removed by capacitor C1. So once this capacitor is removed, this filters are removed, you see very carefully, I am showing you again and again. Now this blue colored wave is AC wave, and this AC wave after C1 will go after variable resistance. So we will get this variable after variable control, variable resistance AC wave. This AC wave will go further to amplifier section, audio pre-amplifier. Now you see what happened. AM detector received modulated signal, and after diode and capacitor combination, this this low frequency signal or audio signal bypass and go to audio pre-amplifier stage. It is weak one, but nowadays we want loud signal. So AF power amplifier will increase this low audio signal to the high power signal, and this power signal low frequency will go to the speaker. Speaker I will cover separately also. There is a combination of magnets and inductance, and result a vibrating, due to vibration acoustic wave will come out, and this you will listen with ears. It's mean now you are receiving the same signal which is broadcasted by the broadcasting station, or I can say by transmitter, and this is Superheterodyne receiver waveform, and of course power supply required. This is not an end of the topic Superheterodyne receiver, because so many terms you have to understand. This topic is still continue. You have to understand this frequency variation, gang control, what happened after AM detector, because we had to control by AGC to the previous IF section to stabilize. We need to use control muting circuit or squelch circuit, so that when no signal is there we can avoid noise. And detector itself is a complicated topic, demodulator, because you have AM, FM, SSB, and in PSK, BPSK, FSK, so many modes are there. So this one is independent, a big separate issues, and everything you have to learn. So some part I will cover in next part. Now it is a time for MCQ, multi-choice question. Whatever you have learned today, you have to explain. First, in a superheterodyne receiver, if IF is 455 kHz, if it is tuned to 1200 kHz, the image frequency will be what? A, B, C, D. I have given answer to you in advance, not asking details, because I know you will face one, but this kind of question may come in the exam. A signal image can interface with the superheterodyne receiver, and it fits the equation. What is the equation? Image is equal to signal plus minus 2 times of IF frequency. And what is the incoming frequency? 1200 kHz. What is the IF frequency? 455 kHz. Both are kHz. Now you have to calculate both frequency. Plus 1200 plus 545 into 2, 2110 kHz. This is higher side. Or other one, difference of 2, lower side 290 kHz. Lower side is normally not coming in band maximum, but higher side is coming. So answer is B, 2110 kHz, 2110 kHz. So if this kind of question is coming, don't do mistake. This question I have taken as an answer form. Now you have to do yourself. Next question. As compared to tuned radio frequency receiver, which of the following is the advantage of using superheterodyne receiver? High gain, better sensitivity, better selectivity at high frequency, stability, noise suppression. Your time start now. Yeah, high gain and better sensitivity is the best answer. Next, what happen in radio receiver if the IF is too low? Image frequency rejection will improve, selective will be too sharp, the frequency selectivity of the local oscillator will have to be lowered, or all of the above. Time started now. Think. Selective will be too sharp, it is not easy to tune. Next, in a radio receiver, the local oscillator is tuned to a frequency lower than the incoming, higher than the incoming, equal to the incoming, or any of the above. Time start now. Yeah, higher than the incoming frequency. One thing always remember, local oscillator is always higher than incoming frequency, and the difference of two is always fixed as a IF frequency of 455 kilohertz. Remember, local oscillator frequency is always higher. The output of diode detector contain what? The detector diode in AM detector section. DC voltage, modulating signal, R ripple, all of the above. Your time starts now. All of the above. Why? Because number one, diode convert AC to DC, and this AC itself is a modulating signal and have wave shaped ripples. Already it was explained to you. Remember, the selectivity of a radio receiver is what? Ability to reject adjacent unwanted signal, ability to amplify weak signal, frequency at which it gives the maximum amplification to signal, its ability to suppress noise. What is selectivity? Time started. Select the desired channel and reject the unwanted channel or signal is called selectivity. Remember it. In superheterodyne receiver, the local oscillator is used to what? Detect the modulating signal, amplifying the received modulated carrier, shift the frequency of the received modulated carrier to the IF band, or none of the above. Time started. Local oscillator is used to shift the frequency of the received modulated signal to the IF band or IF frequency at 455 kHz at fixed value is the work of local oscillator. We are using local oscillator to bring incoming frequency to a constant frequency of IF frequency so that other stage works smoothly, uniform. In a radio receiver, the heterodyne frequency changer is called what? Modulator, mixer, demodulator, frequency translator. This heterodyne frequency changer is called what? Time started now. Choose the right answer. Modulator, mixer, demodulator, frequency translator. Mixer, mixing the frequency. This heterodyne mean mixing. Very first slide it was explained. Standard AM radio broadcasts are confined to what? Medium frequency MF, high frequency, very high frequency, ultra frequency. Time started now. Where you are listening your standard broadcasting station, on which frequencies? Medium frequencies. All musics are broadcasted on medium frequency bands in AM radio. So this is end of my today's session, Principle and Operation Superheterodyne Receiver, and my session is continue on Superheterodyne Part 2. So thank you very much. Now see you in next part. If you really like, kindly press the like button in my channel and subscribe to my channel, because this session is continue, and I hope more videos will help you in education.